We are going to discuss continuity of functions. Let us start with whether the function has a continuity or not at a point. It says that continuous function is a function whose graph is unbroken, with no holes, breaks, jumps or gaps on the entire real line. Based on this given graph at the right, we can see certain points having jump or gap, shaded or solid, and a hole. Thus we can say that there is a continuity and discontinuity at a point. And again, based on the given graph, we can say that the function is not continuous at C, where x equals -2 and x equals 3 because of the jump at x equals -2 and the hole at x equals 3. And the function is only continuous at C where x equals 0 because of the solid point. Let us always remember that a function f is continuous at C if, number 1, f of c is defined or exists. Number 2, the limit of f of x exists as x approaches c. And number 3, the limit of f of x as x approaches c is equal to f of c. Let's have an example. Prove that f of x equals x squared minus 2x plus 1 is continuous at x equals -1. Let us test the first condition, that f of c exists or is defined, by evaluating the given function using the value of x, which is -1. So just simply substitute -1 in x. So we have f of -1 equals -1 squared minus 2 times -1 plus 1. This is equal to, so -1 squared is 1 minus 2 times -1 plus 1. Then f of -1 is equal to 1 plus, so -2 times -1 is +2. So 1 plus 2 plus 1 is 4. Therefore, f of -1 equals 4. Let us now test the second condition by evaluating the limit of the function. So the limit of x squared minus 2x plus 1 as x approaches -1 is equal to the limit of x squared as x approaches -1 using the power theorem minus 2 times the limit of x as x approaches -1 using the constant multiple theorem plus the limit of 1 as x approaches -1 using the constant theorem. And so we have -1 squared minus 2 times -1 plus 1. So we have 1 plus 2 plus 1 equals 4. Let's have the third condition. The limit of the function should be equal to f of c. So the limit of x squared minus 2x plus 1 as x approaches -1 should be equal to f of -1. So the limit of x squared minus 2x plus 1 as x approaches -1 is 4, which is equal to f of -1, which is also 4. Therefore, f of x equals x squared minus 2x plus 1 is continuous at x equals -1 because f of c is defined or exists as f of -1 equals 4. And number 2, the limit of f of x as x approaches c also exists as the limit of x squared minus 2x plus 1 as x approaches -1 equals 4. And number 3, the limit of f of x as x approaches c is equal to f of c, as the limit of f of x as x approaches negative 1 is equal to f of negative 1, which is 4 equals 4. Let's have another example. Prove that f of x equals x plus 1 over x minus 1 is continuous at x equals 1. Let us test the first condition, where f of c should exist or is defined. So we have f of 1 equals x plus 1 over x minus 1. Replacing x by 1, we have 1 plus 1 over 1 minus 1. Then we have 2 over 0, because 1 plus 1 is 2 and 1 minus 1 is 0. Therefore, our result is undefined. And since f of c does not exist, where f of 1 is undefined, then f of x equals x plus 1 over x minus 1 is not continuous at x equals 1. The given rational function becomes undefined or does not exist when its denominator is 0. Let's have some examples. F of x equals x minus 2 over x becomes undefined when x equals 0, because 0 minus 2 over 0 equals negative 2 over 0. Therefore, the function is not continuous at 0. Another, f of x equals x plus 2 over x minus 2 becomes undefined when x equals 2, because 2 plus 2 over 2 minus 2 equals 4 over 0. Therefore, the function is not continuous at 2. Another, f of x equals x plus 2 over x squared becomes undefined when x equals 0, because 0 plus 2 over 0 squared equals 2 over 0. Therefore, the function is not continuous at 0. F of x equals x plus 3 over x squared minus 9 becomes undefined when x equals 3, because 3 plus 3 over 3 squared minus 9 equals 6 over 0, because 3 squared is 9 minus 9 is 0 in the denominator. Therefore, the function is not continuous at 3. And f of x equals x plus 3 over x squared minus 9 becomes undefined when x equals negative 3, because negative 3 plus 3 over negative 3 squared minus 9 equals 0 over 0, because negative 3 plus 3 is 0, then negative 3 squared is 9, minus 9 is 0. Therefore, the function is not continuous at negative 3. To sum it up, f of x equals x plus 3 over x squared minus 9 becomes undefined when x equals 3 and x equals negative 3. Therefore, the function is not continuous at 3 and negative 3.